I'm Max Clark. I've talked about peering interconnection, the internet, the fact that the internet is a global computer network of interconnected networks in the past. Still a mouthful to say every single time. And figured I'd just actually share some examples of this stuff, of how networks are actually built and how do they actually work. This is a network map from Zayo's website. Zayo is a fiber optic provider. They have a lot of metro and long-haul fiber assets in the United States. They have assets outside of the United States. This is a map of their United States markets and how they actually connect. And these are really fun because if I zoom in here a little bit, oops, let's see if I can do this here in a way that makes sense. Here, I'm gonna try this again. Yeah, I can swirl around here. So here's Los Angeles. And if you look at Los Angeles, there actually is cable that connects LA to Santa Barbara to San Luis Obispo. So don't look at this and be like, oh, this map is incorrect. There's this weird cable that's running in the ocean, but it's just a mistake. It's probably actually the cable that's running in the ocean. But if you look at the rest of these cables that run along here, this cable that comes up here to Palmdale and then comes over to Barstow, this cable that comes down here to San Diego, this one that goes from Barstow to Las Vegas, up here we go to Tulare. Let's see if I can grab. Oop, I can't grab. We look at this thing at a larger scale. What you're seeing here is you are seeing the U.S. railroad network in action and where the rail lines actually run. Like, why does this thing here have this little like mountain and this hill in here? I mean, nobody would build a network that had this like random thing here. Well, it's probably because there's some kind of rail depot right here. We have to look it up and see what it actually is that has this indent that brings this cutout. When we are doing a capacity planning and we're talking about redundancy on bigger markets, and I'll use this LA to Las Vegas as an example because I'm doing this a lot right now with people. But you want to have a data center in Los Angeles and you want to put a data center in Las Vegas, and you want redundancy between those two markets. Well, you can't have redundancy on the same path, this direct path between LA and Vegas. Now you could rely on your provider to give you redundancy. And by the way, Zayo has a service and products and things like that where, if this cable cut, Zayo could reroute that traffic across a different path. So you can rely on your fiber provider when you're purchasing, name it whatever you want to call it nowadays. You can call it MPLS, VPLS, wave, dim fiber, dark fiber. Dark fiber doesn't count, but it has to be some sort of lit service. You can rely on the provider to actually give you diversity and redundancy within their own infrastructure. So if this cable breaks here, route this traffic a different direction. Now you wouldn't have control over the routing of which way it goes, or you could then specify, hey, I want this other pathing, and I want this circuit to only be this direction, and I want this other circuit to be this other direction. And then you get into a decision point. In the case of LA to Vegas, do you want to route your traffic for your secondary circuit to Phoenix to San Diego back to Los Angeles, or do you want to route your traffic from Vegas to Reno, Sacramento, and then back down to LA? And why this really matters in capacity planning with these kind of networks is a route between LA and Vegas is pretty quick. It's a sub 10 millisecond network link. Routing from Vegas to Phoenix to San Diego to Los Angeles is a lot more than 10 milliseconds. And the same thing, routing from Vegas to Reno to Sacramento to San Jose and then back down as well is a lot more than 10 milliseconds. If you are doing something on your network that requires a consistent, high-speed, low-latency link, right? What do I mean by this? Usually this is database replication. If you're running any sort of clustering systems for your database between two systems and you're replicating data real time, you want predictability. And if that latency all of a sudden spikes up 4x, your application is going to have a bad time. It is going to freak out on you. Now, that's a really kind of simplistic example of DR between LA and Vegas. And if you look at these markets, there's a reason why a lot of San Francisco or San Jose, Silicon Valley, we'll just use Silicon Valley based sites end up in Salt Lake City. It's seismically stable. You have lots of capacity. You've got a good, nice ring that runs up and down. You can have a this non-direct route, this ring that goes back. And you can also see here how these networks actually physically get built. Again, Los Angeles, if you're going from Los Angeles to, where's a good place on the East Coast? Let's say you want to go from Los Angeles to Ashburn, Virginia, because you want to connect to AWS. You can get a point-to-point circuit from LA to Ashburn. And when you look at that point-to-point, you're only going to see LA and you're going to see Ashburn and you're going to see whatever latency is in between it. Now, in reality, Zayo or whoever else that you're using, Lumen, AT&T, Verizon, we can go down the list, anybody, they're routing the traffic across their backbone. And in this case, that traffic could be going LA to San Diego or LA to Phoenix, to Tucson, to Dallas, to Atlanta, to Charlotte, and then up to Washington. That's pretty common. That's a pretty normal route. Or you could be, for some reason, going to Vegas, Salt Lake, and then to, Denver, and then Omaha, then Chicago, then Cleveland, and over to Vegas. And that happens as well. Elliptical kind of configurations. So you have these redundancies, and that's why you see even here in Edmonton above Calgary, right? You've got two routes that come in. Redundancy, you've kind of got this ring. And Quebec City, like look here, we've got this ring, two network paths. Again, diversity. Fiber gets cut. It happens all the time, and you want to have redundancy with it. So, if you're going out and you're buying network capacity and you have specific link needs and specific latency needs, and you're looking at this and you're trying to figure out how to get from point A to point B, you can actually specify. If you're getting into this, we do this all the time where we're like, hey, we need to provide capacity. We're doing a project up to Modesto right now, and in this case, we want to know what is the actual physical path that's running. What are we actually using? How do we plan redundancy between a primary link and a secondary link? And what is that redundancy actually going to look like? And what will the expectation be for the application and the end user, if there's a service outage on one of these links? Again, it happens a lot. Fiber gets cut. It is a fact of life. Fortunately, the stories of the backhoes randomly digging in fields isn't the problem as much anymore because people kind of understand that that's a big no-no, and if you do that, it's very expensive. But it happens. There was a big cut, a few years ago in the Virginia market, and somebody had a giant auger bit, and they were drilling down, and they got into massive fiber optic trunk cables and just rip that sucker up, and it was a big outage, and it was expensive. I mean, that contractor's insurance company, as provided that they did everything they were supposed to do, it was their insurance company and not the contractor themselves, but it was expensive. Okay, so that's a little bit on US. We can get into details. If you have questions on this stuff, shoot me a note, make a comment, and I'll expand onto this thing. Again, you start with major markets, right? We talk about in terms of football cities usually, right? What are the major football cities? Well, that's where you end up with major population centers as well as major network assets. And if you just kind of look at this, LA, Denver, Salt Lake, Minneapolis, Chicago, right? What do they have in common? Well, major population centers, and they have football teams. So professional sports usually mimic population centers pretty closely. Over here on the left, we see PC1, we see Southern Cross, we see these other things in the ocean, right? AEC1, Apollo South, Durant, GlobeNet. These are oceanic cable systems. And boy, do I love oceanic cable systems. This stuff is fun. So these are the names of the cable. And now PC1, by the way, has a pair. It's never just one cable when they put these things in. Like you see AEC1, AC2. These are when they were built. But so PC1 has a cable that runs into Seattle. There's another one that Zayo apparently is not buying that runs down here into, it actually runs into Grover Beach, right up here in San Luis Obispo area. So here's San Luis Obispo, little black dot right there, Los Osos. PC1's other cable runs into Grover Beach and runs into that market. So we're gonna switch. Let me see if I can switch tabs over here. Share this tab instead. So telegraphy or telegeography. I'm going to go with telegraphy. Creates these really cool maps, and you can buy these things and frame them and put them on your wall. And I've had this for years, and it shows you different cable systems. And you can see here up in the Hudson Bay, we've got this little cable system, which is the Eastern Arctic Undersea Fiber Optic Network. Well, that's a mouthful. And there are places and markets where it is more effective and cheaper to actually build a cable system hopscotches up a coastline versus actually constructing in the country, right? So you see this a lot, in here on the coast of Brazil, and we see this as well coming up from Chile and even Argentina, right? Where instead of the cables necessarily being built in country, they're just hopping around the coast. Same thing, kind of have this same thing happening here in Africa. Let's come around the horn here and look at Asia, because of course this gets really dense really quickly. Lots of islands, lots of cable crossing. Here's that PC1 cable, Pacific Crossing 1. We'll highlight and zoom in onto this in a moment. But you can see here the effect of all these cable maps. Now, fun thing with a lot of these countries in Asia, by the way, is in order to do a cable landing into that country, the landing station, the operator of the network that actually runs into the country has to be majority owned by an entity in that country. So when Global Crossing started building into Asia, they created a subsidiary called Asia Global Crossing, which was, I think, Microsoft and SoftBank, if I remember correctly. SoftBank? I think it's SoftBank. And then they would build the cable in the ocean, and then they would have a partnership with an entity that they were 49% owner of in the actual country, in the actual country. And that company would contract with the landing station, the building, and then pull this cable out into the ocean to when they got into international waters. And then the cable in the international waters would then meet and interconnect and splice in with the actual cable the Asia Global Crossing owned, and off to the races they were, right? And so most of these things have that kind of fun little geopolitical issue. I'm going to come over here to the West Coast, and let's find... So here's Pacific Crossing, PC1. And... boy, there are a lot of cables running between the west coast of the United States and coming over here into Japan. Why is that? Well, first off, short. This is the shortest distance in the ocean between these 2 points, right? So, you want to build cable, you want to do it for the shortest route, you want to get it to where you want to go as quickly as possible, and that's what you have. The other thing you have is you have subfloor geography and terrain. So what's the actual, mountains? Mountains the right term. So mountains and valleys under the ocean affect how you run your cable and how long the cable needs to be and things along those lines. So up here we have Harbor Point, aka Seattle, Washington, and you can see here this cable runs down and also has Grover Beach. So just outside of San Luis Obispo, and this runs over here to Japan in 2 locations. Now this is back to what I was talking about earlier when I was talking about US map. If you look at this thing, it turns into a giant ring. So when the owner of, by the way, it's nice over here, it shows you your landing points and it shows you the website. When you buy capacity on PC1, you get a choice. You can say, hey, I want to buy capacity on PC1 from, here in Harbor Point, Washington, or Seattle, because we're going to interconnect with you in probably Weston Building. And I want to bring it over here and take it to Tokyo. And I only want one path. You could do that. Or you could say, I want one link on the northern route and I want one link on the southern route, and I'm going to interconnect with you here, maybe in San Jose or in Los Angeles, and then vice versa. I'm going to bring it over here, and then I'm going to manage redundancy myself. Or you as a network customer could go to PC1 and you could say, hey, I want to interconnect from the United States to Japan, and I want it to be diverse, and I want you to manage it for me, and I want you to do everything, and I want you to not think about it. And you can do that as well. And it's just layers of service and what kind of control that you want to have and where you actually go. Okay, let's look up another cable. Let's go back to show all cables. Let's look at the cable network that started it all for Global Crossing. This is the folklore of Gary Winnick drawing this on a napkin and selling this sucker like hotcakes to every major company and financial services thing, and like literally basically walking into a law firm and saying, I want all your lawyers. We're going to go back over here to this meeting room at a hotel. We're going to make a contract right now. And we're going to sell this thing. And just basically printing money and starting, a multi-billion-dollar empire. Brookhaven, New York, landing point, runs across. You can see this one coming in here. White Sands Bay. Why is it coming here? Well, it's coming here for London. This is what's taking us into the United Kingdom. And then, of course, it's coming here into Amsterdam and then to Germany. So in another video, I talk about just why is Paris popular? Why is Ashburn popular? Why is Frankfurt popular? Why is London popular? Again, a lot of it becomes this capacity and access to the transoceanic routes, in this case, the Atlantic cables going to the United States, and then also what becomes the terrestrial cable systems that then interconnect, right? So if you're not a lot of cable landings coming into Madrid, Spain, or Barcelona, for instance. So what do you do instead? You build a terrestrial system up to Paris, or you into the Netherlands, but more than likely you're going to France, and then you're going to hop across from there. This is really fun to look at, and we can here's the other thing. So the Mediterranean Sea. Not only are there a lot of cables flowing through this, there's a lot of something else flowing through this stuff. There are ships, a lot of freight traffic, right? So if you look at here, not only is this an oceanic cable system that runs through here, right? But this is the strait. This is the Suez Canal where all the container vessels come in and out of. I'll zoom out a second so you can just see this a little bit bigger, right? This is shipping coming up here and going up this path and going this direction. And what you see every couple months is you hear about some container vessel that was dragging its cable, its anchor, and then they got fouled up on a cable and it cut the cable and the cable system went offline. And if you're talking about a cable system here, depending where it gets cut, I'm spelling this wrong or is it just not coming up here? There we go. So here's this cable. We're doing this live. There we go. Why that becomes a big deal is unlike the Pacific or Atlantic crossings, it's a lot harder to build redundancy between your cable system between South Korea and Amsterdam. Which other direction do you go when you look at this map? Obviously, they decided not to go around Africa, and part of the reason why they didn't do that is because of cost. It's not direct. And it's also probably not economically viable for them to go through Africa because they can't do landings at cell capacity. What happens, and if you're in the United States, you really don't feel this when this happens, but if you're in Europe, I guarantee you felt this once or twice, or if you're in Asia, you've felt this once or twice, is this cable gets cut somewhere in between Greece and Tunisia, usually. And when that happens, all of a sudden, all of your traffic has to route, instead of going between South Korea and Western Europe, it goes and literally hops the other direction and goes to the United States and finds capacity the other way. These things, this isn't like a cable, like a little thing, right? This isn't like your fiber optic patch cord. I mean, these are big cables, I mean, the cable is, it's a few inches in diameter because you have a fiber optic core, and then you've got insulation, and then you've got electrical conductor, more insulation, another electrical conductor, and then an outer layer, and this kind of like armament. And the reason why you've got the electrical conductors is because you have to put power, direct current gets pumped down these cables in addition to the light impulses in the fiber to actually power the regen, the inline amplifier systems that have to regenerate the light as it goes along. I'll just segue into this a little bit. Light degrades over the fiber optic. It's not not glass. It's really like a plastic, a polymer. And so the light only works for so far, right? And so it used to be that you had to have an amplifier every 40 to 8, 40 kilometers and 80 kilometers, now 100 kilometers. Now we see, inline amplifier systems coming out, and cable, it's 200 kilometers. And so that's a pretty big deal because the farther that you can run without having an amplifier system, the cheaper your cable is to put in. So if you're in the ocean, you don't have to have these like torpedo-looking doohickeys that are attached to the cable because they're expensive. And the same thing, if you're terrestrial, you don't have to have an inline system in ILS. It's like they call them huts, right? Like it's literally a building with a generator and cable comes in and it goes through electrical equipment and then it comes out the other side. Anyway, so these cable systems, this stuff is fun. And so you see, there's a lot of geopolitical pressure on this stuff, but then we have some fun stuff that comes up, and, there's networks that before current events, we're talking about building directly over the pole between Canada and Russia. It's much faster to go straight over the pole. We've got other fun cable systems I'll show you here when we zoom in a little bit. Gulf of Mexico fiber optic network. Why would you need a fiber optic network in the Gulf of Mexico connecting Freeport, Texas to Pascagoula, Mississippi? Guess what's in here in this Gulf? These are oil platforms. Gulf of Mexico fiber optic network is connecting oil platforms back to shore for network capacity, voice services, everything, right? You need to have a network connected. Also here, nice fun little Gulf of California cable connecting Baja with what we call mainland Mexico, I guess. And there's a lot of fun, these little things here. I talked in another video about Miami. Boom, here's Miami, and here is all of these cables landing from Miami. Here's where they land. They come up. Everything on the eastern seaboard of Latin America, of South America, Central America, all of the Caribbean, all comes up here into Miami. Some that built the rings, like Mid-Atlantic Crossing, you can see actually built a ring and come up all the way up here into New York. But a lot of these cable systems here terminate in Miami. I'm going to click back over here to the SAO map, and I'm going to connect the dots for you. And look what we have down here in Miami. We have a fiber optic system that follows railroads and then comes up. So here we have Miami, and then here we're connecting back up, and boom. Here's your ring up to Atlanta, major interconnection point. You're in Atlanta. You're now on the on-ramp to the rest of the United States. Anyways, I'm Max Clark, and that was what I thought was going to be a short conversation about cables and turned into a long conversation about cables, and I hope you enjoyed it.